Okay, so what we're looking at here is a kind of continuation of what we've talked about with the chain rule previously. And it's not a really big deal, but these types of problems show up an awful lot more on the AP exam than the other ones that we've looked at so far. Not to say that we don't need the chain rule the way that we learned it before, because we definitely do, and it definitely does show up. But this is going to be a little bit different when we look at this type of chain rule, and you'll see why in just a second. Hopefully by the time we're done with this, you'll be like, oh, okay, that's actually in some ways easier than what we were doing previously. So let's go ahead and get started on what we need to do here. Now, just as a quick reminder, when we see a composite function, that's when we need to use the chain rule. Remember, a composite function is just a function that has a function inside of another function. And usually, like we see it like this, where we've got f of g of x. Remember, our f of x, we call that our outside function, and our g of x is kind of like our inside function, and we use this formula to take the derivative, okay? So as just a quick reminder, if I wanted to take the derivative of sine of x squared minus 2, sine is my outside function, so the derivative of sine is cosine, and then I leave the inside alone, and then I multiply that by the derivative of what's on the inside. Again, we've used this rule several times. Hopefully you remember that and it makes sense, but it has been a little while since we've looked at it, so hopefully that's kind of coming back to you. Not a long time, but it's something to refresh fairly often. Okay, and so what would happen, however, if we didn't know what the function actually was? Like if I had g of x just equals f of 4x, and I wanted to know what that derivative was. The way I would write that derivative is I'd say, okay, I'm going to take the derivative of g, so I'm going to find g prime. Then I would realize that f is my outside function and 4x is my inside function. So I would still use the chain rule the way I've used it before. I would just go f prime, and then I would leave the inside alone, and then I would multiply that by the derivative of what is on the inside, which would be 4. Now, I know that derivative looks kind of weird, especially since we don't know what the function is, but we still carried out the derivative process using the chain rule like we've done previously. So again, hopefully that kind of makes sense as far as what it is that we're doing in these problems, that at least a little bit different, because this is what we're going to see. Instead of seeing actual functions, or at least complete and total functions, we're going to see functions like this, where we have g of x equaling something that is a composite function. I want to know what the derivative is, and then I'm actually going to evaluate. So let's take a look at, let's say we had that same thing, okay, where g of x was equal to f of 4x. And I want to know what g prime of 1 is. Well, in order to do that, we've got to think, okay, I've got to take the derivative first. So I've got to find g prime of x equals, we just talked about this, f prime of 4x times 4. Once we have that, we say, okay, I'm going to take 1 and I'm going to plug that in for where I see x. So I'm going to have g prime of 1 is equal to f prime of 4 times 1, which is 4, times 4. Now this is where this is going to differ from what we've done previously. At this point in every other problem that we've done with the chain rule, especially if we were trying to evaluate, which we really haven't done very much, but if I wanted to plug a number in at this point, I would just plug it in everywhere I saw x, and then I would just multiply, add, divide, whatever I needed to do. In this problem, I need to know what f prime of 4 is, and that's why I have this table of values. So I look at this, I'm like, okay, f prime of 4. Well, there's two different lines here. I've got f of x, I've got f prime of x. F prime of 4 is saying I'm going to take 4, so here's my 4 right here, that's my x value, and I'm going to put that in to my first derivative to see what that is. 4, when I plug it in, you can see here hopefully that I get negative 3. So I put negative 3 here, and then I have that multiplying by 4, so what I get in this answer is negative 12 for g prime of 1. Again, hopefully that kind of makes sense. We're going to do some more examples here, but let's take a look at the steps that we should take when we have this type of problem to find the derivative. Step number 1 is we need to take the derivative of the function, okay? And we're going to use whatever rule. Sometimes it's a product rule. Sometimes it's a quotient rule. A lot of times it is a chain rule, but it doesn't matter what the function is. Just take the derivative like you normally would. Step number 2 is we're going to take the x value that we're being asked to find the derivative at, and we're going to insert that into the derivative that we just found. And we kind of did that earlier, and we'll look at some more examples here in just a second. Step number 3 is we're going to evaluate the derivative using the table of values. We've got to use the table of values to find out what each of those are. And they'll always be set up so that you can do that. And then a lot of times on these tables, what will happen is you'll see a bunch of values that you never used. Usually on the AP exam, or problems in general, in calculus anyway, you're not given a piece of information that you don't need. But on these tables, there are certain values that exist, not to throw you off necessarily, but to make sure you understand what it is that you're doing in the problem. Okay, so we already looked at that one. Let's take a look at this one, okay? Very similar to what we had before, but you'll notice I've got a plus x squared, and I want to find g prime of x. So step number 1, I'm going to take that derivative. So I get f prime of 4x. Again, I take the derivative of my outside function. Then I multiply that by the derivative of what's on the inside. And that is the derivative of f of 4x. But I've got this x squared on the end, so I have to take the derivative of that. I know what that function is, so I can use that power rule to just take the derivative easily there. Step number 2 is I'm going to plug 1 in everywhere that I see an x. I'm going to have f prime of 4 times 4 plus 2. F prime of 4, we found that earlier. We know already that this is negative 3 times 4, but this time there's that plus 2 on the end, 2 times 1, which is 2. There's the 2 on the end because we had x squared. So negative 12 plus 2, this time we get negative 10. So that x squared on the end did make a difference, and I used the table to evaluate it in step 3 there. Now let's say we had a slightly more complicated table that had a couple of different functions and their derivative values on it. Let's say I had m of x is equal to g of f of x, and I wanted to find m prime of 5. So again, that's asking me to take the derivative of this and then plug in 5. Well, in order to do that, I'm going to take my derivative first. So m prime of x is equal to, g is my outside function, so I take the derivative of the outside function, and I leave the inside function alone, just like we did. Even though it's weird that f of x is on the inside, we just leave it alone. Then we multiply by the derivative of what's on the inside. So there's my step number 1. Second thing I always do is plug 5 in everywhere that I see x. So I get g prime of f of 5 times f prime of 5. Now this is where these get a little bit tricky, because I need to know what f of 5 is. So I go up to the table and I can see that f of 5 is equal to 4. So I'm going to go g prime of 4, because that's what f of 5 equals. And I'm going to multiply that by f prime of 5. Well, now again, this is asking me something slightly different. I want to know what g prime of 4 is. So I go to g prime of 4, that's 8, multiplied by f prime of 5. So I go to f prime, I go over to 5, that's 2. 8 times 2 in this case is equal to 16. Once you get the hang of these problems, they're actually a fair amount easier as far as the algebraic manipulation or like doing any sort of arithmetic is than doing the other types of problems. You got to get used to them before they get easier. Okay? Let's say we had a slightly different function, f of g of 2x. And I want to know what w prime of 1 is if that's what w of x is. So step number 1, I need to take the derivative of that. So I'm going to go w prime of x is equal to derivative of the outside, f prime. I leave the inside function alone, g of 2x. Then I multiply by the derivative of the inside function. Well, I have another composite function on the inside, so I have to take the derivative of g, which is g prime of 2x. I leave that inside 2x alone. Then I multiply by 2. So there's my first step. Now I need to take whatever number it is. So in this case, I'm going to plug 1 in. F prime of g of 2 times 1 is 2, multiplied by g prime of 2 times 2. So now I need to find out what g of 2 is. So I go to the table, I got g of 2 is equal to 5, so I got f prime of 5. Again, that's way easier because I don't have to evaluate anything. The values are already there. So then f prime of 5, I can see f prime of 5 is 2. G prime of 2 is negative 2 times 2. So 2 times negative 2 times 2 gives me negative 8. That's my answer for this one. Let's take a look at one more just to make sure we got it down. Okay, let's say I had f of 2x multiplied by g of 4x. So if I have this one, I want to first of all take my derivative. So I'm going to go f w prime of x is equal to, first function is f of 2x. I can see I'm using a product rule here, multiplied by the derivative of the second function. So I go g prime of 4x, but then I need to multiply by 4. plus the second function times the derivative of the first function. And hopefully, again, you can see how I'm using the chain rule to take the derivative of the first and second function. Once I do that, I'm just going to plug my numbers in that I got. So I've got f of 4 times g prime of 8, and all of that's multiplied by 4, plus g of 8 times f prime of 4, and then we're going to multiply that by 2. So f of 4, I go to my table, that's 2. G prime of 8 is 3, so I get 2 times 3 times 4. Plus g of 8 is negative 2 times f prime of 4 is negative 3. And then I times that by 2. Okay, so I get 24 plus that 612 plus 12 is equal to 36. Again, hopefully these problems kind of make sense. There's a couple extra steps as far as writing them out that kind of makes them a little bit more difficult. But once we get to this point right here, we just start using the table of value to plug numbers in, it actually hopefully makes a lot more sense. If you have any questions about this or anything else, please let me know.